Hi everyone, this is 8th grade Elevate Lesson 53 on modeling relationships with functions. Today we are specifically trying to find our rate of change and initial value given information in the form of a table or a word problem. And so jumping into question letter A, you are going to model this question taking about 4 minutes to do so. So it tells us you can find the rate of change and initial value from data pairs. There are a few different formulas that we are going to highlight with this first model. So you might want to have students write these formulas down, or you might want to have students take notes as you're going through them. The first formula is the slope formula, the first formula that we're going to be using is rate of change. So the change in y over the change in x. That is our slope. The second formula that we are going to use is y equals mx plus b. So m is our slope. Once we find our slope, we are going to plug in some of the data points that we've been given in our word problem or our table to plug in values for our x and our y. So let's start. It tells us that the table shows the number of forms that are on a clerk's desk X minutes after starting time. So a clerk walks in to work. She has 0 forms on her desk because she just walked in. However, 20 minutes into her day, she has 70 forms on her desk. And then 60 minutes into her day, she has 150 forms. So you can only imagine 5 hours into her day, she's probably going to be swamped with forms, right? If the number of forms changes at a constant rate, find the rate of change and the initial value. So rate of change, we need to find our slope. The change in y values, so here is our y values. Change tells us we need to subtract. So I need to do 150 minus 70. 150 minus 70 gives me 80. After I do my change in y, I need to figure out my change in x. So my x values are 20 and 60. I have to do 60 minus 20. That gives me 40. The slope formula is change in y divided by change in x. So I need to do 80 divided by 40. That gives me a slope of 2. Now that I know that my slope is 2, I can plug in, remember the other formula we're working with is y equals mx plus b. My m is what I just found to be 2. So instead of y equals mx plus b, now I'm working with y equals 2x plus b. From there, I can substitute a data pair to find the y-intercept. So I can choose whether I want to use the numbers 20 and 70 for my y and my x, or maybe I want to use 60 and 150 for my y and my x. It doesn't matter. I will get the same answer because my forms are changing. It says that my forms are changing at a constant rate, meaning that it doesn't matter. Meaning that it doesn't matter which values I choose, I'm going to have the same constant. So let's go ahead and plug in 20 and 70 for my y and my x. When I plug in 20 and 70 and I do the math, I end up with a y-intercept of 30. That means that the rate of change is 30 forms per minute. And you do not have to worry about formulas for this particular lesson. So from there, you are going to go ahead and model questions 3 and question 7 for kiddos. using the same information that you've been given. Now, that question that we just worked on had a table. This question does not have a table. It tells you that a feather falls from a 100-foot cliff at a rate of 15 feet per minute. So rate of change can be the change in y over the change in x. It can also be distance over time, d over t. So because it tells us that the distance is 15 feet per minute, this is where we get 15 over 1, which is just 15. 15 feet per minute. And then it tells us that a feather falls from a 100-foot cliff. So it falls from, that means it's our initial value. Okay? Easy question. Question 7 is a bit more challenging, and which is why I want you to model this question. It says 2 years after a car is purchased, it is worth $24,000. 2 years after it is purchased, it is worth this, right? So that means when it was purchased, it was probably worth more. So we're going to have to figure out what that initial value was, right? It tells us 5 years after it was purchased, it was worth $15,000. So you can obviously see that the amount is declining the longer it has been purchased. In 2 years, after 2 years, it was worth $24,000. After 5 years, it was worth $15,000. So you can only imagine after 10 years, it's probably worth like $5,000, right? So we have to find the rate of change. We have been given 2 of those values. That is our distance, 24,000 minus 15,000. And then we have been given our time. We had 2 years and then we had 5 years. So 5 minus 2. When we do 9,000 divided by 3, we get 3,000. The reason why we are accounting for this negative is because we know that the amount is going down every year. We are not gaining money every year. We're actually losing money every year. So that rate of change is actually negative, okay? So now we are going to use this negative 3,000 to figure out our initial value. So again, rate of change is our m value. So instead, we're going to use the formula y equals mx plus b. And instead of m, we are going to use negative 3,000. So we're going to use y equals negative 3,000x plus b, right? From there, we are going to plug in either 2 and 24,000, or we're going to plug in 5 and 15,000. For our x and our y, and that is going to give us $6,000 that we have lost after 2 years. We're going to add that 6,000 to the 24,000 to give us a total of 30,000. This lesson is a bit challenging just because of the 2 different formulas that students are having to use. So I can anticipate that students are probably not going to get to their exit ticket today. What I will say is try to focus on this first page right here, getting kids through questions 3 through 8. And then if you have time, definitely try to see if they understand question 9 on their own. But it is okay if they need extra practice on this particular skill.